last part of section 2.2, really going to look at three things. First thing we're going to look at is how do we do basically what we've been doing all week, finding the 6 trig functions. But now we're not just going to do angles that are in the first quadrant. That's what we did yesterday when we had the 30, the 45, and the 60. Now what we can do is we can look at multiples of those. So instead of just 30, you could do 120, because that's 30 times 4. Instead of just 45, you could do 45 times 3, which is 135. So as long as a number is a multiple of 30 or 45, we can still do it exactly the way we did it yesterday. Just coordinates are going to be very similar. The 1/2, the root 3 over 2, and the root 2 over 2. Those are the 3 numbers you still need to know. So basically, we're just looking at the same triangles again, except they're going to be reflected into other quadrants. So we'll see what that does to the coordinate when you mirror image it. The other thing we're going to look at is we've done unit circle all week. Unit circle means the circle is how big?
1 unit.
1 unit has a radius of 1. We didn't have to use a radius of 1. I told you on Monday I picked 1 because it just made the arithmetic the easiest way to do it to start to teach you about unit circle trig. But we could use a circle with radius 2 or 12. It doesn't matter, right? If the radius isn't 1, it adds in a step to the arithmetic, but all the formulas and stuff like that stay pretty much the same. Okay? So we'll talk a little about that. And then the last thing we're going to do is look at what if we have an angle that's not a multiple of 30 or 45. Right? So what if I gave you a problem like find the sine of 13? 13 is not something you're going to be able to find the coordinate for. It's got to be a multiple of 30 or 45. So when we have one like that, we're going to use the calculator. Right? So I'll show you how to do that. So as far as kind of explaining stuff for this first part, there's really nothing to explain. We're using the same triangles from yesterday. So we'll just start off with an example. This is going to be the only example that I do all 6 today. After this one, I'm going to pick 1 trig function per problem, like cosecant or sine, okay, just 1 per problem, like the test. All right. So Michael, anytime we want to do trigonometry on the circle and they give us the angle, what's the first thing that you have to figure out?
Coordinates.
You've got to figure out the coordinate. Yep. Once we know the coordinate, this is exactly the same as what we've done all week. You just have to figure out the coordinate. All right. So first thing you want to kind of think about is what kind of problem this is. There's really 2 different triangles that we're working with. You've got the 30, 60, 90, and you've got the 45, 45, 90. Let's try to put 135 on that circle, and then you'll know which triangle you're dealing with. And once you know that, then you're going to know, is it the root 2 over 2's, or is it the one with the root 3 over 2, 1/2? So here's 90, 0, 180. And we want to figure out where 135 is.
Yeah. Right in between 180 and 190.
Right. It's exactly halfway between 90 and 180. So let's make a triangle out of it. And the goal to find the coordinate is to figure out how long this side is. That's your x. And then how tall this side is. That's your y. But that triangle is either going to be this one or this one. And we already know how long all the sides are in both of those triangles. That's what we did yesterday. So that triangle that I have right here, do you think that's the 45-45 or the 30-60?
45-45.
Yeah, it's the 45-45. And if you're not sure why, look at 135 and ask yourself, what do you add to 90 to get to there, 135? To get from 90 to 135, you added 45, which means this part is 45 degrees to get from 90 to the hypotenuse. Well, if that's 45, then that has to be 45 too. Because right there, that part in blue, that's a 90. So they both have to be 45. So it's just, if you have plenty of room, you can just keep going there. I'm just going to make the triangle bigger after the side. So that's a 45 because of what we just figured out. And all the angles in a triangle have to add up to what? They all have to add up to 180. So if that's a 90 and that's a 45, that's a 45. Okay. Basically, if we're dealing with an angle that ends in a 5, it can't be a multiple of 30. It's not possible. Multiples of 30 and then 0. So think about it that way. Okay, how long is each side in the 45, 45, 90? They're both what number? Yeah, go ahead, Jay. They're both square root of 2 over 2. This side is root 2 over 2. This side is root 2 over 2. But you have to be careful when you write your coordinate because you're in quadrant 2. So what's going to happen when I write my coordinate that didn't happen yesterday? Yeah? Yeah. In this case, because we're in quadrant 2, the x is negative. That's the only thing that's different. So there's your coordinate for 135. Now from here, it's exactly the same as what we've been doing. If you forget the negative, then you're really giving me the coordinate for 45. That's not what you want. You wanted 135. Okay. Any questions on how we got that coordinate? All right. So now we just go through our functions. Okay, so Larissa, what would my sine be in this case? Yep. It's my y, which is root 2 over 2. This time, because they're different, if you mess up the x and the y, if you switch them, you'll end up getting it wrong. When the x and the y are the same, then if you make a mistake, you kind of get away with it, but you should know which one is which. So sine is the y. Joe, what about my cosine? Yep. That's my cosine. And Kyle, how about my tangent?
Would be -1.
Yep. So you're dividing two things that are opposites. Whenever you divide opposites, like 3 divided by -3, the answer is -1. Okay. Now that you've got the 3 on the left, you don't really even have to remember different formulas for the 3 on the right. You just have to remember to take the 3 on the left and do what? Flip them. Okay, just flip each one of them. Well, I'm going to do that one first just because that's quick. You flip -1, you get -1. And how about when you flip root 2 over 2? Remember what you get when you root 2. You just get root 2. So if that one's root 2, what's the secant? Negative root 2. Okay, so same rule. If you get a square root in the bottom, you have to fix it just like we've done before. But having a negative there doesn't change how you fix anything. It's still the same. Okay. Any questions on finding the 6 trig functions of 135? Okay. So now we'll try one per problem. So we'll try 45 angles and 30-degree angles in all different quadrants. Not every single problem you could have, but we'll just try a bunch of different ones. All right, so we've got cosecant of pi over 4. Samantha, what's the first thing that we got to figure out? Okay, why are you converting it to degrees? Okay, so if it's easier for you, you can change it to degrees. If you can get the coordinate right from that, that's fine too, right? Most people aren't as comfortable with the radians, so they change it to degrees. So we can do that. That's optional, but yes, you can do it. What do you get when you convert pi over 4 to degrees? Do you remember what you multiply?
It's 45.
multiply by 180, divide by pi. So you're left with 180 divided by 4, which is 45. Okay. So if that makes it easier for you to find the coordinate, you can do that first. But now you got to write the coordinate. So Sheridan, what's the coordinate for 45 degrees?
Root 2 over 2.
Yep.
Root 2.
So there's our coordinate. For that one, I just remember it because it's in the first quadrant. You don't really have to think about negatives. Also, they're both root 2 over 2. So you don't have to think about, wait, which one do I put first? The 1/2 or the root 3 over 2? That's the other one. So that's usually a pretty easy one to remember. All right. Got that. You got your coordinate. And now they want the cosecant. Which one do we flip to get the cosecant? Do you flip the x or do you flip the y? Yeah. And again, in this case, it wouldn't matter. But you want to flip that one. So when we flip that, you get 2 over the square root of 2. And we just did that in the last problem. Square root of 2. So you kind of notice when you're dealing with the 45s, you're always going to get answers like square root of 2 over 2, square root of 2, 1, or negatives of what I just said. Those are pretty much the answers you always get. 30s and 60s, those are different numbers. Those are the 1/2s and the square root of 3s. Okay. But any questions on the cosecant? Okay, so 2 things I'd be looking for on the test. Did you find the right coordinate? And then did you give me the right answer? Just like on the homework. All right, let's try this one. Sine 225. So this definitely is an angle that's not in the first quadrant. So sometimes the sketch is a little bit helpful. Bless you.
Thank you.
So you can figure out, wait, should I have x negative? Should I have y negative? Should I have both negative? So we'll figure that out. Here's our circle. And we got to figure out where 225 is. So where's 225 on that? Yep.
It would be 45 degrees in between 180 and 270.
Yeah, 225 is exactly halfway between 270 and 180. So that's going to put it right there. And anytime you're dealing with an angle that ends in a 5, that's your 45, 45, 90 triangle. At least for what we're doing. I'm not saying every number in math ending in a 5 is a multiple of 45. 25. But I'm going to give you numbers that are always multiples of 45 or 30 to do this stuff. Okay, so this side is root 2 over 2. That side is root 2 over 2. When you write the coordinate, though, just be careful.
I was going to say both coordinates would be negative, wouldn't they?
Yep, they're both negative. And technically, to do this problem, you didn't even need the whole coordinate. All you needed to do the sign was the what? All you needed was the y. Okay. So the y value here is negative root 2 over 2. So I'm just going to put an arrow to that because the sine of 225 does not equal that coordinate. The sine of 225 equals negative square root 2 over 2. That's just the location for the coordinate. That's the answer to the problem. Okay, questions on that one? All right, let's try one more. Cosine 7 pi over 4. Okay, so this is one, if you want to do it like we did a couple problems ago, you'd want to change the radians to degrees first. So, Anna, what do I multiply by to change this to degrees?
180 over pi.
Yeah, 180 over pi. And usually if you reduce it enough, sometimes you can do this part without a calculator. How many times does 4 go into 180? 45? And 7 times 45 is going to give me how much? 315. So that's not the answer to the problem. All you've done is rewrite the problem in a way that maybe it's easier for you now to figure out the coordinate. All right, so here's 270. That's 0, which is the same as 360, all the way around. Where's 315? Yep.
Root 2 over 2, comma, negative root 2.
All right, so we're going to be right here. Positive root 2 over 2, negative root 2 over 2. So let's put the coordinate. And again, like the last one, you actually didn't even need the whole coordinate here. All you need to focus on is the what value? The x, which is root 2 over 2. Well, I shouldn't say you don't need the whole coordinate. I'm going to ask you for the coordinate on the test, so you're still going to have to write it, but you only have to use part of it to get the answer. Okay. So that's a 45-degree angle in every quadrant. I didn't do every trig function of every 45, like we could have done the sine, the tangent, the secant, the cosecant, and the cotangent. But I just picked just the cosine. Any questions on that? All right, so 45s aren't as bad because you know both numbers are root 2 over 2. You don't have to worry about the order. When you get into the multiples of 30, now we have to worry about, okay, is it positive, negative, and also which one comes first, the 1/2 or the root 3 over 2. So for that, the best thing to do is just make a sketch. All right, so we got 0, 90, 180. And you can label the whole thing if you want. Where's 120?
30, right after 30.
30 degrees past 90. So it's closer to 90, right? Your three options are basically, is it right in the middle? Is it closer to 180 or is it closer to 90, right? It's definitely closer to 90. So draw it, you know. That might be exaggerated a little closer than it really is, but that's fine. So that's where I'm going to put 120.
Would the point be negative square root of 3 over 2 and 1/2?
Let's take a look and see
Okay.
which one has to go where. So make your triangle. And once you draw your triangle, you should be able to see which side is the short one and which one is the long one. That's the short one. Right? The long one is right here. When we write the length of the short side, don't worry if it's positive or negative yet, but how long is the short side always? The short side is always 1/2. And the long side?
Root 3 over 2.
3 over 2. So my x value is the red one. Okay? That's the short one. My y value is the long one. That's the green one. So we just got to make sure we get the signs right. So what would be my coordinate for 120? Yeah.
A negative 1/2. Square root of 3.
So negative 1/2 square root 3 over 2. Right. So we've got the coordinate. And now to find the tangent. Ariel, what's my formula for tangent? Y divided by x. Okay, when I go to divide those, what happens right away?
You can cross out the 2s.
Yep. You cross out the 2's. And now you're left with this. Again, when you have a negative in a fraction, it doesn't matter where you put it. I usually just put it in the top. And since it's just divided by 1, you can just do that. Right? So the tangent of 120 is negative square root of 3. Right. Questions on that one? Yeah.
Why isn't it square root 3 over 2?
Square root of 3 over 2, 1/2 would be when you have a point more over here. Like that would be 150. And then you draw your triangle. And now when you draw your triangle, the long side is right there. So when you have square root of 3 over 2 first, That's when the long side is on the x-axis. But in this case, the long side was going up and down. I'm going to show you guys a diagram in a little bit that basically has all of the triangles for every problem drawn at the same time. So it looks a little confusing, but what we really want to look at is just the pattern. Not trying to memorize the whole diagram. Because even just drawing 2 triangles on here, it starts to look more confusing. So imagine drawing, all 3 in the first quadrant, second, third, and fourth. You got 12 triangles in the same picture. But it's a good diagram that kind of summarizes everything we've learned for the week. Once we go through it. Okay, let's try secant 690. So this one's in degrees, so that's good. Most people like it in degrees. But it has another problem we've talked about. Yep. Yep. We want to subtract 360 so we can see, rather than going around a couple times and then stopping, all we care about is where you stop. So it's easier if you just subtract 360. What do you get if you subtract 360? 330. All right. So now 330, that should be one we can visualize where it is. It's in the 4th quadrant. Is it right in the middle, closer to 270 or closer to 360? Yeah. So this is going to be the one that has the root 3 over 2 first. Okay. So let's put 330 right there. Make our triangle. That's the long side in green, and then the short side is in red. So Sadie, when we write the long side, what's the length of that? So that's square root 3 over 2. And Dennis, the short side?
1/2.
1/2. Right. So now let's make our coordinate and then write the answer. So coordinate here, which value is going to be negative? The y. So you're going to go right, square root 3 over 2. Then you're going to go down 1/2. Okay, secant. Which one do you flip to get secant? The x. Okay. So the x in this case is root 3 over 2. When you flip it and fix it, final answer would be, what is it, Joe? Yep, 2 square roots of 3 over 3. Okay. Any questions on that? Okay. There's a lot of these. You can keep going with them. But does anyone feel like they need to see another one of this type? Like 5 or 6 of them. So that's another one. I'm going to skip it. But if I was going to do it, the first thing I would do is change it to degrees. Even once I do that, I would still have a problem with this. It would still be negative. So I can add 360. And then once I do that, the answer you get, it's going to be either a multiple of 30 or 45. If you did that one, that's going to come out to, let's see, pi over 6 is 30 times 7. That's negative 210. So then when you add 360 to it, you're going to get 150. So that's going to be the cosecant of 150. And the coordinate for that would be negative square root 3 over 2, comma, 1/2. And then go from there to find the cosecant. All right, so let's take a look at that. So what this diagram shows you is every single coordinate we've done, both in degrees and radians with the triangles drawn. But I just kind of want to look at the patterns. I don't want to try to memorize everything that's there. Even though it's really not a lot to memorize because it's a lot of repeats. So the red triangles are all your square root 2 over 2s. Those are all your 45s. The only difference is sometimes you have a negative with x, negative with y, or negative with both. The green triangles, those are all your square root 3 over 2 1/2. Sometimes they're both positive, sometimes they're both negative, sometimes one of each. And the blue triangles, those are all your 1/2 root 3 over 2s. So, as long as you know those three, you can figure out any of the other ones. And in fact, even in those three, there's only three different numbers. 1/2, root 3 over 2, root 2 over 2. So if you can remember those three fractions, that covers every single point on that circle. Notice that they're not all evenly spaced. The 30, the 45, and the 60 are kind of clustered together in the middle. You're missing the 15s. You're missing the point that would be here, and you're missing the point that would be there to make them all equally spaced. You can do the 15s, but it's not something that we do. What else? Don't forget about the easy ones we did on Monday. 1, 0, 0, negative 1. Some people start getting in the habit of the 30, 60 and the 45, 45, and then they forget the 0 and 1 stuff. Those are the easiest ones, because you don't have any square roots. If you have a number divided by 0, what's that? Undefined. That only comes up with the 30, with the 0, 90, 180, 270. Because undefined can only happen if there's a 0 in the coordinate. What about 0 divided by a number? 0. Okay, so any questions on that? All right, let's take a look at the second thing. So, all week I pretty much told you that we've been using a unit circle. You don't have to use a unit circle. Use any circle you want. Doesn't make a difference. So, let's say this is our unit circle. And I'm going to put a point on that circle, like right there. If that was a unit circle, all you would do is you would put your triangle in the unit circle, just like that. You would find the coordinate, and then you would plug the coordinate into whichever formula you needed. The y, the x, flip it if you had to flip it, divide them if it was tangent, okay, whatever you had to do. Now what we're doing is almost like we're extending that side out a little bit. Okay, we're just taking that triangle that we had, and instead of doing it on a circle that's a radius of 1, maybe we're making a triangle now on a circle that's a radius of, I don't know, maybe that's like a radius of 5. It's hard to, can't get it because it uncouples itself when I do that and start breaking it apart. So. All right, we're good. So now we're looking at it on a circle that is bigger than radius 1. Okay, any question on that so far? Now, if you look at the green triangle and the red triangle, they're similar. Similar means one of them is just an enlargement of the other. Okay? They're not congruent because they're not exactly the same size, but they're similar. So the idea here is if you can figure out this coordinate, you can still do it the same way we've been doing it because these two triangles are similar. Right? The only thing you have to take into account is that you're not on a circle of radius 1. You have to take into account how big of a circle you're on now. Okay, so that's the extra step, finding the length, finding the radius of that bigger circle. All right. So let's look at a pattern here. So let's say we have a larger circle. And then I'm going to write here scale by to make 1. All right, so what I'm going to do is I'm going to make a chart, and I want to see, all right, if my circle is larger than a radius of 1, tell me what I would have to scale it by to make it 1 again. So what I'm trying to do is take this green triangle and turn it back into the red triangle, because we know how to do the red triangle problem. The green triangle is too big. It's on a circle that's bigger. So if we can take that green triangle and scale it, make it smaller, shrink it down, then we can turn it back into the red triangle and do the problem just like we've always done. So let's say your larger circle had a radius of 3. What would you have to scale that circle by to shrink it back down and make it a unit circle?
What is like scale by?
Scale? It's like if you have like a scale model of something, like if they say it's a 1/2 scale model of a car, it means everything is like half the size of the original. So when you scale by, it's like what you're shrinking it by. If you scale it by 3, that makes it 3 times larger.
3? 1/3.
1/3. Okay? So if you had a circle that was radius 3, and you wanted to shrink it back down to a unit circle, because that's what we know how to do, you would scale it by 1/3. What if you had a circle of radius 5? If you scaled it by 1/5, you would make it back to the original size that we've been working with all week. One more, and then we're going to kind of generalize it. What if your circle was a 12? You'd scale it by 1/12. Now, what if your circle was a radius of r? What would you scale it by to make it 1?
1 over r.
1 over r. That's the key. If you divide by r, that's what makes this formula work, right? So all you have to do is this. In our original circle, we had x. That was the letter we used. In the new circle, we're going to divide it by r. Why are we dividing it by r? Same reason we divided by r right there. Dividing by r takes your circle, it scales it down, and it turns it back into the unit circle. So we're taking the problem we don't know how to do, and we're turning it back into the problem we do know how to do. And we're doing it exactly like Colby said, divide by r. Or he said 1 over r, which means divide by r. Okay? So if you take the radius and divide by r, you have to divide everything by r. Think about, like, if you wanted to make this piece of paper smaller and keep it proportional, I can't just make it half as wide. I have to make it half as wide and half as tall. I have to shrink everything together. Right? If I only shrink one dimension of this rectangle, it's going to change shape. Right? I have to shrink the whole thing together. Right? So x is going to be divided by r, and y is going to be divided by r. So that is going to be the key. So we're going to take all the formulas that I gave you on Monday, and everywhere we had an x, we're going to put divide by r. Everywhere we had a y, we're going to put divide by r. And that's taking the problem we don't know how to do and shrinking it back to the problem we do know how to do. But the reason I did this is so you could kind of see the pattern. 3, 1 over 3. 5, 1 over 5. 12, divide by 12. R, divide by r. That's the key. Divide by the radius. Doesn't matter if it's 3, 5, 12, whatever the number is, you divide by it. So let's look at our 6 formulas for now doing trig on a circle of any radius. Could be 1, could be 3, could be 19. Doesn't matter what the radius is. So, what did we have for sine originally? What letter?
Y.
Y. And I said to take y and replace it with y over r. For cosine, we had x. we're going to replace x with x over r. What did we have for tangent?
Y over X.
It was y over x. And remember what we're doing here. Y gets changed to y over r. X gets changed to x over r. So that's our new tangent formula. But what happens there?
The R.
The r cancels, so really the formula for tangent stays the same. It's still y over x because the r cancels out and it doesn't matter. Now, once you have the 3 on the left, what do we always do to get the 3 on the right? Flip them. So your cosecant is r over y. How about your secant?
R.
R over x. And how about your cotangent? X over y. Now, I'm going to write something on the board. I don't want you to copy it down because I want you to leave that exactly the way you had it. When we learned this on Monday, we did a unit circle. What was the radius of the unit circle? 1. So watch what happens if you fill in 1s to all these others. Those are exactly the formulas I taught you on Monday. So the formulas that I really taught you were these formulas. I just decided to fill a 1 in for all the r's for you. Now, you're going to have to find what r is yourself. Could be a 2, could be a 3, but you have to find it. Okay? So that's the extra step. Find r. And find the coordinate just like you always do. But in fact, I'll give you the coordinate for this kind of problem. You won't even have to find that. All you're going to have to worry about is r. So let's try an example. In case I didn't make that clear, r is the radius. But I think I said it. Okay, so here's a coordinate. 5, 12. This coordinate represents an angle on the circle somewhere. What angle? Who cares? This is back to what we did on Monday. You don't have to worry about what the angle is. I'm telling you where it is. That's all you need to know. Okay. The 5 is which letter? The first number in a coordinate is always your what? That's your x. That's 1. You get that. The second number is your y. So you've got your x, you've got your y, but there's one more letter you need to use these formulas. You need r. So let's graph. I'm just going to get a piece of graph paper for a second and graph the point 512 and see if we can figure out r. Okay, and I'll come right back to that page. All right, so let's do this one. All right, so 5, 12. 1, 2, 3, 4, 5. I know that's 10, 11, 12. Okay, so I went right 5, and I went up 12. And that point is on the edge of a circle. What circle? The circle. Right there. So that's a point on the edge of that circle. Now, is that the unit circle? No, it's way bigger than the unit circle. Unit circle would be right here. So what we're going to do is we have to figure out how big of a circle are we on. So what I need to figure out is that. How would I figure that out? Yeah, how did you figure that out? Yeah. This side is 5. 5 on the bottom. This side is 12. And as long as you have 2 sides in a right triangle, the third side is, you can use the Pythagorean theorem. So that's the extra step. You have to use the Pythagorean theorem to find r. Now, I picked one that does come out nice, but if you're not sure how he got 13, 5 squared plus 12 squared, and we'll call this my radius. What's 5 squared? 12 squared? And if you add 144 and 25,
169.
you get 169. And then if you take the square root of that, you do get 13. It might not always come out to a nice number, but this time it did. If it doesn't come out to a nice number, that's fine. You know how to deal with that. You might get square roots in the bottom, and then you fix it like you always do. But because I gave you guys a nice number here, there's no square roots in this. So now you know how big of a circle you were on. Circle of radius 13. So let's add that letter right here. R equals 13. There's X, there's Y, there's R. Now just fill it in to whichever ones they want. I think in this one I only asked for the first three. So let's start with sine. What would be my sine in this one? Yeah. Right. It would normally just be 12, but that's on a circle that's 13 times bigger than it should be. We have to divide it by R, and that scales it back down to the unit circle. What about cosine? Yep. If you put 5, that's on a circle that's 13 times too big. So we're going to scale it down. X over R. Okay? And the last one, tangent. R doesn't play a part in that. So tangent is just Y over X. And if I did ask for the other three, what would you do with those? Just flip them. Okay? And these would be nice because there's no roots, so you're just going to get 13 twelfths, 13 fifths, 5 twelfths. Okay, so on a problem like this, because you already have to find R, I'm not going to make you find the coordinate. I would give you the coordinate. I kind of have to give it to you. So you will always have the coordinate. You'll just have to find R.
Are there ways to find it out without anything? Like just knowing? Or like having one point?
Well, to find R, I have to give you two numbers.
Oh.
I can't just give you one number, no. It'd kind of be like if I said to you, graph this coordinate.
Yeah.
Well, I can't. I'm missing half of it. You can't do that. So, yeah, you'll always be given those two numbers. Yep. Okay, so any question on that? So, doing trig on a circle that's not radius r, it's pretty much the same. All right, so last thing. Everything that we've done so far, I've either given you a coordinate right off the bat, like this one, and said, don't worry about what the angle is, you don't need to know. But that's the coordinate for some angle somewhere. Or I've given you an angle, but it's been an angle that is a multiple of 30 or 60 or 45, and then you can find the coordinate. Well, now we're going to look at what happens if none of that happens. I'm not giving you a coordinate right away, and I'm not giving you an angle that's a multiple of 30 or 45. So the only way you can solve it is just to type it in. Right? So for these last few, we're going to use a calculator. All right. So let's look at example 8. Can someone just read to me, what does example 8 say? Okay, yep, so those are the directions. And then what's the actual problem?
Sine.
Yes, and the very last word you said, that's important. Sine of 18 degrees. If there's a degree symbol in the problem, then you need to make sure your calculator is in degrees. Okay. So on my calculators, there's a button at the top that says DRG. On the ones that look like this, you press the DRG button at the top, you'll get a choice of 3 things. Degrees is the first one. You can just use the arrows, and it'll underline the choice that you want. You always know what mode you're in on this calculator, because if you look at the main screen, there's DEG. If you press the button, change it to radians, then it'll say RAD. Okay, we'll use that, but not for this problem. Okay?
What's GRD?
GRD is gradients. It's not something we learn. We just stick with degrees and radians. But there are other ways to measure angles besides those two. Okay, so I'm going to go to my calculator. Mine's a little different, but same idea. Mine says radians at the top, so this is the wrong mode. Okay. I can type it in, and it'll definitely give me an answer, but that's not right at all. That's the sine of 18 radians. That answer would be correct for that problem. But that problem, I got to put it in degrees first. So on mine, I have to press mode, and I see a couple people have one like this. Highlight degree, hit enter, and now it'll say degrees at the top. Okay, so whether you're using one of mine or one like this, it tells you on the screen what mode you're in. If you have a Casio one, it's totally different. I can show you how to do it, but I always have to figure it out. If you don't like the Casio because you're not sure how to use it the day of a test, you could use one of mine. Okay. All right, so let's type it in. Sine of 18. I'm in degrees. I hit enter, and I get 0.309. Okay. If you got 0.309, you did it right. Anybody? How many people got 0.309? Okay. And on a test, I will make it clear how many decimal places I would like you to round to. It's usually 2 or 3. I'm going to do 3 right now. Okay. Let's look at this one. Cosine of 356 degrees. Okay. So this problem, it's the same mode as the last one. Okay. Put it in degrees. Okay. Let's type it in. Okay. You should get 0.998. So let's say one like this was multiple choice. And I gave you a few different choices. Let me bring this back up. All right, so I gave you choices of 356, 0.998. What was that other one? Negative 0.540. And a dot. So, out of those choices, one of them is correct for this problem. 0.998 is the correct choice for that question. Any concern why it's 0.998? Now, if I do that, the correct answer is now C. Because that's the cosine of 356 radians. And I did that off to the side real quick. All right. So you just have to be careful when you read the problem. Look at what they're putting right here. That's called the argument. The argument is just the thing you're taking the cosine of. Right? That's not multiplication. That's just the cosine of 356. Just like this. That's not multiplication. It doesn't mean square root symbol times 12. It means the square root of 12. It's just the thing you're doing to the 12. You're square rooting it. This is the thing you're doing to the 356. You're cosining it. Okay? But just check the units and make sure you're in the right units. Okay. Tangent. What would I have to do first on this problem if my calculator was set up for the last two? You'd have to change to radians. That's the tangent of 2.4 radians. So make sure your calculator's in radians. Type tangent 2.4, and you should get negative 0.916. Now, I don't know any calculator that's like this, but let's say you had a calculator, it was a scientific calculator, and it didn't have a way to change it to radians. How could you still do this problem on a calculator that didn't have a button for radians? Yeah? Yeah, you could change this to degrees by hand if you had to, right? So if your calculator doesn't have radians on it, you could change this to degrees manually and then type it in that way. That's more work. If your calculator has a radian button, I would just use that. But if it didn't, you could change to degrees by hand, okay, and use your calculator.
So if it doesn't have the degree.
Yes. Yeah. All right, so we did sine, we did cosine, we did tangent. Let's do cosecant. Well, first thing right away is put it back in degrees. So you don't forget that. What I would probably do if I had this on a test is I would look for all the problems that are in degrees, and I would just do all those, and then I would do all the problems that are in radians. So that way I don't have to keep switching. Like if I go degrees in problem 9, and then radians in problem 10, back to degrees. That way you don't have to keep switching. That's up to you. Okay, so I'm in the right mode, and I'm looking for cosecant. Okay, whether you're looking at that calculator or this one, or the one that you have, do you see a button on there that says CSC? No. There is no button for CSC. So the only way to get CSC is the same way we've been getting CSC all week. To get the one over here, what do? Flip what? Flip the sign. So the only way to get the cosecant is to take the sign and flip it. So that's exactly what we're going to do. So what I'm going to do is 1 divided by sine of 247. That puts the sign in the bottom of a fraction, flips it, and that gives me my answer. Now, if you didn't want to type it in that way, you could do it like this. You could say, all right, I'm going to find the sine of 247 first, and then I'm going to do 1 divided by the answer that was last on the screen. 1 divided by the last answer flips it. But either way, you get the same. I think the first way is easier. So negative 1.086. Okay, let's try this one. How would I type in the one that's on the board right now? Yeah? Yep. Yes. 1 divided by cosine of 6. And make sure that it's in radians. I'm not. I'm in degrees. Go to radians. And we get 1.041. Okay. Any questions on that one? Now, I didn't ask this, but why didn't we do 247 and try to find the coordinate? What's it supposed to be a multiple of? Yeah, so that's not a multiple of 30 or 45. So there's no way you're going to be able to find the coordinate for that. Let's try this one. Cotangent of 13 degrees. So Anthony, how would I type in cotangent of 13 degrees?
Would be 1 divided by tangent. Oh, you have to put the calculator.
Yeah, in my calculator, I can change the mode right up until I hit enter. So if you've already typed it in, that's okay. You can still go change the mode to degrees, and you're good. On your calculator, you might have to change the mode before you start the problem. I don't know. Depends on your calculator. Right. And you get 4.331. Okay. Any questions on that? All right, so we finished up looking at the 30s and the 45s and all the other quadrants. We looked at what happens if you have a circle that doesn't have a radius of 1. And the last thing was how to use the calculator. Okay. So that finishes up everything that's on this week's test. That's everything. So what we'll do is give you guys the homework. Tomorrow I'll give you a review that's similar to questions you're going to see on the test. And then if we finish it, we might go over it. If we don't finish it in class, then that'll be the homework tomorrow night. And then we'll go over it on Friday before the test. Okay, so homework for tonight, 49 to 57 odd. You'll be able to do that without a calculator. 67 to 81 all. Those are calculator problems. So if you don't have a calculator at home, you might want to do 67 to 81 now, unless you can get at a calculator somehow. Okay. 83 and 84, you can do those without a calculator. Right, but I'll keep the calculators out if you need them, and you've got about 15 minutes.